how do you break into data science, break into a data science career. So I'll be giving you 5 actionable and practical tips. And first of all, right, obviously, before you break into data science, you really need to break into data science. But the thing is, data science, like, if I'm sure that this is not your very first time hearing the term data science, right? So you must have saw it in some news articles. You must have heard it from your friends or your relatives or your senior, your senpai who are in the data line, especially those of them who are in IT or computer science, right? They would have mentioned this to you. And also another way of getting to know data science, of course, you watch those conferences, like people like Elon Musk, Jack Ma has been talking about data science for many years. But for you, right, the problem is that what is data science actually? So and to define the problem clearer, what makes data science unique and what makes data science so special, right? So in order to understand data science, in order for you to break into data science career, you need to understand 3 major components, which is computer science, mathematics, and domain knowledge. Now, when we say computer science, right, we are not saying that you must understand all the workings behind computers. So that's more of the operating system or more of the architecture. But what you really need to know in terms of computer science are things like data structures, algorithms, for example. So you don't really need to become a computer scientist, or you don't really need to come from an IT background in order to practice data science. But you need to have a broad understanding about what computer science is about. So what sort of problems computer is solving, right? If you watch the movies like the movies about the Imitation Game, right? It's about Alan Turing. So it talks about how they break the secret code or the passphrase of the Germans, right, during the World War II. So these are a bit of the background knowledge about computer science. But what you really need to know is what sort of problems computers are solving, right? And that goes with mathematics as well. So when we talk about computer science and mathematics together, when we talk about data science, is actually we are talking about what sort of mathematical problem, what sort of mathematical approach, statistics, models that you are going to pick based on the problem that you are trying to solve, right? And the problem we are talking about here is not a specific mathematical problem. For example, we are not telling you that you need to find the next prime numbers, or how to do the factorizations, or xn plus yn equals to zn, that sort of things. But what you really need to know is, like, okay, for example, you want to forecast your sales and revenue for your company next month, all right, or next quarter, and your company is selling real estate property. Okay, so what sort of models that you should pick? So that's a mathematic problem, right? And then you need to know enough computer knowledge to apply and implement a solutions, to write some scripts and then use some code, use some software to help you to execute the mathematics problem. Now, the main motivation behind this is the data that we are handling today is no longer able to just calculate it manually using your hand. So a lot of mathematical models, statistical models that we used to do in the past, now we can use computers or machines to help us to do that. And that's why when you combine these two together, computer science and mathematics, it gives you machine learning, right? It's nothing but just getting the computers to train the models, fit the curve for us using data and using the traditional mathematics model. So, but what personally I consider domain knowledge is the most important part in data science, right? Because knowing computer science and knowing mathematics is just knowing how to solve the problem. But the main I think the main challenge or the hardest part in data science is you really need to know how to ask the right questions. Okay, now once you have the domain knowledge, it means that you can ask the right question. Today, with all the powerful computers, quantum computing, you can easily crack passwords, you can easily find answers from Google's indexing, all sort of things. So finding answers is no longer a challenge for everybody. But the hardest part in this equation in data science is the domain knowledge. All right, so the first thing, if you want to break into data science, is to make sure that you have these 3 key knowledge, right? Domain expertise, domain knowledge, you know computer science, know a bit of programming, know how to implement those mathematical models using computers, right? With all these three things together, then you know how to get into the right mindset of data science. Second thing is a counterintuitive opinion, which is pick your specializations. Now, a lot of time when it comes to learning data science, right, people are told that you need to learn a lot of things, right? Whenever we go for any sort of conferences, any sort of event, people will just say, oh, you want to become a data scientist, sure, but you have to be careful, right? Because there are a lot of things in data science. For example, this picture, okay, you basically just, I'm sure that a lot of you here are, you were told too much information, right? TMI, or information overload, which I don't blame anybody, because most of the time the information was delivered to you not by a practitioner. It probably by somebody who doing data research, probably somebody who is doing machine learning. So give you an example, right? If you look at this picture, it's like the blinds are touching the elephant. So when you ask somebody about data science, if this person is in the industry, he will probably say that, oh, you know what, data science is about AI. Yeah, the cutting edge technologies now is AI. And if this person is from a data engineers or from a networking background, then he will tell you that, you know what, data science is about big data, because if you don't have big data, you can't train the models, you can't teach the machines, right? Which is not wrong. And then you have all sort of buzzwords flying around, right? ABCDs, AI, you have blockchains, and then you have cloud computing, and then you have big data, you have programming, and then people will argue, you know, in our industry, people argue about, oh, Python or R, or which one is more important. But the truth is, yeah, hey, I'm going to debunk a myth for you. You don't have to master everything at the very beginning. It took me 15 to 20 years just to, well, sort of master everything, but I do have my specializations, okay? And otherwise it will be overwhelming. When you try to master everything, you know nothing, right? So give you an example. These are some of the broad topics or the area of in data science that you can choose to be focused on. So often when you try to look for some resources or guides, when they teach you try to break into data science, right, they expect you to be familiar with fields like mathematics, statistics, and natural language processing, and it's impossible to master everything at the very beginning. I can tell you the truth, right? Even if you complete a uni degree, master degree in 4 years, you are not going to master everything. Okay, this is the truth. Yeah, so I give you an example, right? So when I first started, I started off with data analysis, because if you look at these 8 areas, right, 8 pillars, I got to be very frank with you. I'm very, very bad at visualizations. Okay, I'm not somebody who can visualize very well. So if you're familiar with learning mechanisms, they are VAK, they are visuals, they are auditory, and they are kinetic. So I'm more towards the kinetic type. So I'm somebody who needs to touch, who needs to feel, and I can just write and then type some code, then I will remember. All right. So when I started my data science journey, I'm an IT student's major in database. So I started off with data analysis. I look at different types of data, like categorical data, numerical data, and all sort of different data. And then I start to learn how to analyze them. That's how I started. But then later on, because once you get a lot of data, right, you will get lazy. Because there are a lot of mundane, a lot of repetitive work there. And as a programmer myself, right, I came from a software engineering background, right? I'm a programmer. So I start to look into ways that I can automatically extract information, insights, useful insights from this data. So that's where I started doing machine learning. Okay, so this is where I get into different types of models. So I learned how to use data mining methods. So back then at my time in Australia, right, we do data mining. We don't call it, we don't have a fancy nice name like data science, like what we have right now. And well, of course, today if I tell people that I'm doing mining, data mining, people probably think like, oh, so you're mining Bitcoin, and then they will start to chase me for the price of Ethereum or Bitcoin. Yeah. So after machine learning, right, the next thing that I learned, then only I learned visualizations. Now the reason why I learned most of the reasons that I learned all this stuff, right? This is my journey, yeah. By the way, this is my personal journey. Uh, the reason why I learned visualization is very simple, because I'm 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 lazy to explain things to my supervisor, my PhD supervisor, my project supervisor, and a lot of time you need to explain over and over again. And you guess what? Those uni lecturers, right? They have very short term memory. They, like my PhD supervisor with me for 3-4 years, right? Yeah, he can't really remember most of the time. What am I doing? So visualizations, pictures speaks 1,000 words. Then only I start to pick up visualization, and visualization is not just about drawing charts. Yeah, it's about presenting your data effectively and communicate so that it can help you to communicate your idea across to your audience. For example, you can use infographics, you can use a bar chart. You need to know when is the best time to use a table, when's the best time to use a column chart, when's the best time to use a line chart. And all these have very strong and well-researched information display theory behind them. And that's why I got a tip for you here is don't use pie chart, okay? By all means, don't use pie chart. If you have attended my classes before, you know why, yeah? If not, you can leave me your thoughts there in the comment section, and let's see whether you can guess my intention of not using pie chart or not. Okay, and then, sorry, I clicked on the wrong stuff. Yeah. After that, right, after I have picked up visualizations, the next thing that I learned is NLP, which is natural language processing. So NLP stands for natural language processing, which is a specialized field, a specialized subject that we teach computers to understand text. Like a lot of people will think that NLP is just like, for example, text to speech, right? When you read a text, it converts into speech, or Google is built on top of NLP, YouTube is built on top of NLP. But there are a lot of useful applications for NLP. Yeah, for those of you who are interested in unstructured data, who are interested in things like Siri, Alexa, Google Home, that sort of stuff, all of this is built on top of NLP. And even those very advanced techniques, like for example chatbots, okay, automatic question answering system, Google Translate, they're all NLP, yeah, natural language processing. Basically, in layman's terms, to teach the machine to understand human language. Right? Natural language means human language, and then artificial language is like programming languages. So it has a lot of values there. Yeah. So when I did my PhD, I specialized in machine learning using NLP, and I took an even harder subject, which is called short text understanding. Understanding long text is easy because the context is there, but short text, usually their meaning is very concise, very precise, and it's very hard to interpret them and extract topics from there. But that's a topic for another day. Just for you to know, if you're interested in, for me, because after I have done my master's, right, I got again, I got bored with numbers. Like if you try to analyze structured data, is always that few ways, linear regression, logistic regressions, and stuff. And so you can see that I skip mathematics and statistics for a large part. I only managed to pick up mathematics notation at the end of towards the end of my PhD, because I need to graduate. Yeah, because I need to graduate, so I have no choice, but I have to learn how to write mathematics notations and all those fancy stuff. But if you know how to do it, right, mathematics notations and programming, they're actually the same thing. It's just written using different syntax. Okay, so here's a tip for you. If you know that if you came from a mathematics background, a statistics background, if you want to become a data scientist, machine learning engineer, then you have different path. So here leads to another question, right? How do you choose which areas to specialize when you want to break into data science? So the best way to choose which area to specialize is look at your career path, right? Take a couple of minutes, take a couple of days to think about what do you want to do, what do you want to become. So let me give an example. Yeah, let's say today you want to become a data engineer, right? You want to become a data engineer. So data engineers is somebody who look after the entire data architectures, entire data platform, and every big companies, they will have a dedicated data engineering team to look after their data platform, so that the data, when the data comes in, they know how to collect the data, where to disseminate the data, where to store the data. If you can think of it this way, right? Let's say you are AirAsia, or you are Grab, or you are Faith. You have a lot of customers, you have a lot of data points, you have a lot of transactions, right? So every time when you collect those data, where should you keep them? Are you going to keep all of them in the same server? Obviously not, right? Because some of the data, like customers' data, they're not real-time data. They're not live data. Usually your customers enter their details once, and that details will stay there for a long time. So you need to separate them into different servers and stuff. So if you want to become a data engineer, you should be focusing on things like big data analytics and also data engineering. So big data analytics helps you to familiarize with cloud solutions. For example, you need to know how to set up AWS, Google Cloud, or Microsoft Azure, and also the use of big data platforms like Hadoop or Redshift. Right? You need to know how to collect data, store data in a scalable fashion. Alright, this is a keyword, scalable, and so that the system can run under a consistent performance. Whether you are serving 10,000 customers or you are serving 1 million users, they should run consistently. So you need to be able to design and architect a platform that's able to scale automatically and perform consistently, no matter how many users that you're serving. Okay, and at the optimum cost. Yeah, and second part is data engineering. So data engineering skills including things like setting up data pipelines, gather data from different resources, for example web API, CSV file, SQL tables, and then you have some advanced topics like data security, data governance, who should have the access to a certain servers, who should have access to certain tables, and this is all the access authority stuff, right, to prevent data leakage and privacy breach. I'm sure some of you have read the news today about Lazada's data breach incidents, right? Yeah, so this all fall under the umbrella of data engineering. Okay, now this is data engineering is a career path that suits those people who came from let's say you are a network administrator, so you have database management background. Data engineer is a career path that suits you. All right. Now, another very common position in data science team is data analyst. Data analyst, if you want to become a data analyst, then you require different skill sets. So the one that I have highlighted, right, are the core skills that you need to master. I'm not saying you don't have to pick up machine learning, mathematics, or data engineering. Less important for you. Like for example, data analyst, you still need a bit of data engineering skills if you want to become a good one. So you know where to get the data, where to store the data. But it's not a deal breaker. Like you wouldn't go for the interview, and if the interviewer asks you, do you know how to set up AWS? And then if you say no, then you say, oh sorry, I'm not going to hire you. Yeah, it's not scenario like that. Okay, not that sort of situation. But definitely you need to master things like statistics, visualizations, and data analysis. Okay, and so let's talk about statistics first. A lot of time when people talk about statistics, they got I would say not headache lah, not as bad as headache, but your head is start to spin. All right, when I hear the word statistics, my head start to spin a little bit, because a lot of terminologies you see in statistics, right, are designed, or they are the language or the lingo spoken within the community. So like they say t-test, they say hypothesis testing, they got null hypothesis, they got type 1 error, type 2 error. Basically they mean something in the real life, but for example type 1 and type 2 error actually is just referring to false positive or false negatives. But if I tell you it's false positive, false negative, you can easily understand, right? But if I say, oh no, this is a type 1 error, then you'll be like, what is a type 1 error? And then when I talk about hypothesis testing and then null hypothesis, they all map to something in real life. So first thing first, you need to pick up the language used in statistics and understand the formula. For example, Pareto distribution. Yeah, you probably, most of you never heard of it before, right? But that is actually what we call 80-20 rules. Yeah, and then normal distribution. Some people heard of it, some people did not. But actually, in real life, is what we call the bell curve. Yeah, so things like that lah. So statistics is something that you must pick up, and you need to know how to apply them. And most of the numbers, right? Let's say standard deviations, mean, mode, minimum, maximums, average, arithmetic mean, that sort of things. They are just a way for us to use numbers to represent something, and using this number to represent something is for us to do comparison. For example, mean, right? The average weight in a particular groups of people versus average weight in another group of people. Let's say we are trying to compare the obesity in Malaysia and Singapore, right? So we are going to compare the average weight of Malaysian men between 25 to 35 years old versus average weight of Singaporean male between 25 to 35 years old, for example. And then we see which group is heavier. So we can we don't have to, if not, you have to collect, like, let's say 1,000 Singapore male which is around that age compared to another 1,000 Malaysian male which is at that age, and then so what? Yeah, you need to be able to compress that information into a single value so that that value is representative enough for you to compare the results. Okay, but after you compare the results, then you realize that the average is not sufficient to represent the spread of the numbers, right? It can be the maximum, minimum is different, but it average out. But that's the purpose of averaging numbers. So then you need standard deviations to see how far apart are the data points, and so on. All right, so enough on statistics, yeah. And second thing, it will be visualization. So visualizations, I think I have covered a little bit earlier on, but here the visualizations that a data analyst needs is beyond just using charts. You need somebody who you need to become somebody who is good in designing dashboards. And when you have dashboards, you have dashboards like operational dashboards and also strategic planning dashboard. These are the two common dashboards that you need to use. So you need to know when is the right time to use a strategic dashboard, what sort of data you need, what sort of elements that you need to put together, and then when do you need to use an operational dashboard. Yeah, because their frequency is different, so frequency of use is different, and the scenario, context, and use cases are different, so you need to know. So on top of building charts, you need to know how to create dashboards, and you need to know what are the popular dashboards software out there. For example, is Excel sufficient? Okay, and if not, you need to buy some professional software like Tableau, Power BI, Google Dashboard, but yeah, Google Dashboards. And you need to know the price difference and their limitations, pros and cons. Okay, and the last but not least is data analysis. The data analysis skills that a data analyst needs, right, that require, are not as heavy as a data scientist, which I'll cover next. Yeah, and the data analysis skills that you need to have are probably more on the again, statistical parts, and more on the historical data part, or what we call the descriptive analytics. Yeah, and the sort of descriptive analytics that we talked about here, right, is about let me give you an example. Okay, in our class, right, we do have things like let's say HR analytics, for example. So when you analyze HR, you need to know what sort of data that you need to collect. You need to collect their departments, you need to collect their salary, you need to collect the number of years that they have spent in the company, and then you need to know their evaluation score, yeah, and also whether they got promotion in the past 5 years or not. And based on these, you can start to analyze a goal, right? You need to have a business question. I've emphasized this many times, is that you need to have a business question. You need to have a well-defined business question. So let's say you want to find out the attrition rate. Attrition rate means why people leaving the company. So when you are trying to understand why people leave the company, and then you can use different descriptive analytics to help you to understand, okay, is it because they are not happy in the company, is it because they were assigned too many projects, or they work too many hours in a month. So this sort of analysis and this sort of descriptive analytics is what you need as a data analyst. All right. And last but not least, this is the thing that you have been waiting for, right? Data scientist. So the reason why data scientist is so popular or so in demand right now is that a lot of industry, let's talk about, let's use COVID as a divider, yeah? Before COVID, a lot of companies, they are aware that they have a lot of data sitting there in their data silos. All right, I give you an example. Yeah, any corporates that you go in, they will have at least 3 to 4 different systems running. They have their CRM, customer relationship management. They have their ERP, enterprise resource planning system. They have HR system. They have finance system. They have these are already 4 systems, right? Then they have payroll. They have inventory, and depending on whether they are doing service, they are in the service industry or they are in the retail industry. So if they are selling products, then you have transactions. If they are in the service industry, then you have debtors, you have creditors, and you have I think I covered most of that. Oh yeah, and the procurement system as well. So you need to do spend analysis. So before COVID, right, these companies, they're trying to gain a competitive edge by analyzing data so that they can move faster or move forwards before their competitors catch up. All right. So after COVID, right? After COVID, these companies are still doing the same thing, but we have another groups of companies. They try to catch up now. Okay, they try to digitalize their business, so you generate a lot of new data, and on top of that, the old companies, some of the companies who have already started building models, doing analysis, analytics, right? They realize that the models that they built before COVID and after COVID is totally different. Yeah, because COVID changes a lot of things, right? And so that's why suddenly data scientists, the demand for data scientists reach another new high. Yeah, put it this way. But I can tell you the truth. Yeah, speaking from my experience in the industry, is that you will see that a lot of people, they say, yeah, but it seems like not many companies are hiring data scientists, right? Yeah, you must be thinking like, Dr. Lau, this doesn't sound true. But if you go and speak to any company and ask them, like, are you willing, or are you planning to hire a data scientist? Then they will definitely say yes. I haven't. Basically, you find me a company that say, oh no lah, I don't want to do anything with data. Yeah, no. I prefer paper and pen, that sort of things. No company will say that. So the gap here is that HR doesn't really know how to hire data scientists. Okay, now as a data scientist, so you need to educate them sometimes, and you need to be able to present yourself. Yeah, you need to know how to package yourself. The key difference between a data scientist and a data analyst is this. Data analysts, usually their role, their task is very specific. When a company hires a data scientist, right, data analyst, right, they'll hire them for a specific role. For example, fraud analyst, for example, web analyst, social media analyst, finance analyst. Even if you go to research house, right, they will have very dedicated person. They wouldn't hire a generic or general data analyst. Usually they don't, right? Like a lot of our students, they work in Grab, they work in Touch and Go, they work in those are payment e-wallets division, right? Their job is risk analyst, fraud analyst, for example. Yeah. But when you work as data scientist, you see things at a different level. You have to manage things from end to end. So you need to come up with their data science strategy for the entire company. Okay, so therefore you need, on top of data analysis, which I've covered, and visualizations, you also need machine learning skills. Yeah, a big part of data scientist career is to clean data, gather data and clean data. Sorry to tell you that 80%, 70%, 80% of our time are actually cleaning data, because we know that if you don't have high quality and clean data, the machine learning models that you build, right, will not be accurate, and it will bite you sometimes, because your data is dirty, garbage in, garbage out. But that gives you the ability to predict the future. The reason why we learn machine learning is we want to be able to predict the future, but predict the future with certainties. And the keywords here is certainties, because if you simply, or if you merely want to predict the future only, you don't need data scientists, right? Any fortune teller, or no offense, tarot cards, they're sort of fortune tellers outside the temple, they can do future prediction, right? You know that there are a lot of gurus there teach you all the marketing, not to say marketing, sorry, stocks, and then how to predict the markets, right? For share markets, they will tell you like either go up or go down only, man. Yeah, it's easier for them to say. But what you really want to do is you want to be able to predict futures with certainties. So that's why you learn machine learning. So you learn how to build predictive models. And I've also highlighted NLPs here, right? Once again, natural language processing. The reason behind NLP is very important because NLP will take your game to another level. Right, once again, NLP will take your game to another level. Let me explain to you why. In many companies, all right, whether you are in many organizations, let's say you are in the retail company, right? What is the main thing apart from your sales? Yeah, in the retail scenario, right, in the e-commerce shops, the most important part of your company is actually your product. And how do you know your product or services are good or bad? You need to look at the reviews, right? And people usually nowadays, when they have bad feedback, they don't call you, they don't do anything. They straight away go to social media and write something about it. If they love your service is 11 stars out of 5 stars. They love it so much, they're so amazed, then they will say good things about you on Twitter, Facebook, maybe not LinkedIn, but mainly go to Facebook, Twitters, and places like that to talk about your services, right? And your services is bad. If your food is terrible, they will also go around and tell people, right? They will go to Facebook, Twitter again, just to bash you. So that's why NLP is very important, because all this sort of unstructured data and can only be analyzed by using NLP. Yeah, you need to know how to crawl data. You need to know how to go around and collect this sort of data to understand what people talk about you, right? Let's say if you sell your products on Amazon, right? You need to know whether people are giving you four stars, 5 stars. If people are constantly giving you 1 or 2 stars, and you need to know why. Right? If people constantly give you 5 stars, and you also need to know why. So you need to know what you've done correctly, what you have done wrong. And second thing, in another scenario, is about understanding the topics, understanding the discussion. Sometimes it's not about yourself, about your product, but it's about the entire industry. For example, politicians. Right? Politicians use these two a lot. They do a lot of social media listening. They go to Facebook, they go to Twitter. They need to understand what the rakyat is talking about. All right, you might be seeing that now it's COVID, yeah, but some people, their concern is moratorium, right? So maybe their main concern is, can I extend my installment payment for another 6 months? But some people in different states, all their concern is whether there's a lockdown or not, and the main reasons, motivations behind lockdown is different. And that's why I'm not going to give you full details here, but you can take a look, like Harvard Business Review. They talk about all these sort of things like Cambridge Analytica, Obama, Trump, how they use social medias, listening, natural language processing to understand people's mind, yeah, their voters' mind. So this helps them a lot in winning their elections. Okay, so if you are a data scientist, make sure that you master all these. And mathematics, statistics, big data, data engineering, they are also important, but not the top priorities, I would say, right? Especially the focus of the talks tonight is to teach you how to break into data science. And even if you are just a complete beginners, and even if you are just uni graduate and you're listening to this live, right? You know that although you learn most of them during your universities, but after you have graduated, you need to pick those areas that you want to specialize. Yeah, okay? Any questions, leave them in the comment section. All right, we'll come back to that later. Now, next thing you need to do is to learn the tools. Okay, after we spend so much time talking about the first two topic. After you know what is data science, okay, you know that which skills that you want to specialize. The next thing that you need to do is actually to learn the tools. Learning the tools is okay. First thing first. Why do you need to learn the tools? Because in data science, you need to do a lot of boring and repetitive tasks, right? Before you can get to the sexy part, full stop. And the boring part includes things like how to extract data, how to transform data, and how to load data, right? This is extract, transform, and load. And this is what we call the ETL process, basically. So I'm going to show you three tools. Right? I'm going to show you three tools that is open source and free that you can download and use, and straight away learn how to after you have learned that, then you can use these tools to analyze the data. The two most popular computer programming language for data science, right, is actually Python or R. And if you already know one of them, right, there's no need for you to switch. All right, once again, I repeat, if you already know any of these, you don't have the need to switch. Yeah, most of the companies, they accept either one unless they specifically mention that I only want to hire R programmer. So who hires R programmer only usually are those research house, academic research, or companies, organizations who invested heavily into R early stage when they're doing their most of the time research, most of the time. Okay, but in larger companies like Facebook, Grab, Uber, that sort of scenario, even like our own company, right, when we're serving clients project, it doesn't matter that much. It doesn't really matter that much, especially when you are handling the project by yourself. Unless you're working in a team or group environment, they say you must know R. Okay, and same goes to Python. Now, if you don't know any of these, okay, you don't have any programming knowledge, or you probably know Java, JavaScript, you came from a web development background, right? Then my suggestions will be going to pick up Python first. Okay, pick up Python first, because Python is a beginner friendly programming language, and the syntax is easier relatively compared to R, and it has a lot of packages out there, and it has not to say R doesn't have it. Python and R, they have rich amount of libraries and packages, but most important thing is you can do a lot of things with Python. Yeah, you can use it for automation, you can use it to build websites, you can use it for scripting and yada yada. So Python is more like a Swiss knife programming language, and R is an excellent, powerful analysis tool. Okay, and when you become more senior, right, the chances are you are going to interchange between these two. These are just like tools in your under your belt, or in your toolbox. So yeah, consider them like either them are tools, and then just pick one, whichever is appropriate. Some of the libraries, most of the libraries, they have equivalent versions in Python and R, unless you are doing very specialized version. Okay, I know some questions that the next question that you have, right? Some of you, if you're watching this, you might be wondering, like, Dr. Lau, I might not have computer science or IT background. Doesn't mean that you shut my door from entering data science. Okay, no, that's not the case. Of course, I will still advise you to learn Python or R first. It may be you are like, I'm not sure whether data science suits me or not. Can I just get a taste of data science? Or maybe you have tried programming before, but you are confirmed that you certified that programming is not for you. Okay, I have seen people like that before, especially when I was teaching in uni, right? They are people who are diagnosed with code phobia. Like you know, some people who cannot read, right? When they see, like normal people, they can see words properly, like we can arrange and susun ayat, we can arrange our sentences properly. Some people just can't, and we do have some people, they're just weak in logic, so they can't figure out how computer science or IT programming works. That's perfectly fine. It doesn't mean that you cannot pick up or learn data science. And I'm going to recommend another free tool for you, which is called the Orange. If you really don't have a computer science or IT background and you would like to try out data science, learn the algorithms, learn the workflow, go with a tool called Orange. Now, Orange is a workflow based tool. Basically, it allow us to create even this is a complex version of a data science workflow algorithm, but what I'm trying to show you is that even in a scenario as complex as this, Orange can handle them very well. Yeah, so if you're looking something that's more visuals, more component based, more workflow based, Orange is for you. Okay, yeah, highly recommend. So Python, R, or Orange, you can try out either of these. They're all free and open source for you to download. Okay, and next thing is my step 4, yeah, which is to craft a plan. Right? A lot of people, when they learn data science, they got hot-headed. I'm sure that by now, when you are listening to my talk here, right, you're very excited. Oh yeah, I'm so pumped. I want to be the next Dr. Lau. Okay, I want to be the next Andrew Ng. I want to be the next Yen Le Kun. I want to be the next Elon Musk. All right, but after this workshop, okay, usually like after the talks, after the workshop, you turn cold because you don't know what to do next, right? So I'm going to step 4 is going to tell you to craft a plan. Another mistake that I've seen in a lot of people who try to learn data science, they're not my students, but those people who try to self-learn, they bought a lot of videos, they bought a lot of online course, Coursera, Udemy, that's fine, but they are not self-motivated, and also they don't have the support mechanism, so they felt burnt out after a while, right? Yeah, because they don't have the support. So how do you craft a plan? Speaking from experience, statistically, our students are able to pick up data science by spending 1 hour a day for 12 weeks. So after they have completed data science 360s or some of our workshops, right? Most of them, they're able to pick up data science by spending 1 hour a day. Yeah. Take note. Yeah. Take note. Getting a job and pick up the skills are totally different things, right? Getting a job depends on how I'll tell you how to get a job in next slides, and also by the end of the entire series I'll share with you all how do you actually get a job. Yeah, but the most important part here is that don't forget to set a target, but don't set yourself a hard target. Like, I'm going to learn data science in 7 days. Okay, you can see that there are a lot of people out there, they are teaching things like, or get certified and become a data scientist in 5 days. You know that is impossible, right? You know that's impossible because it requires a lot of practice to pick up data science. So my suggestions, what we have seen considered as a proven tested recipe, is that spend 1 hour a day, right, and craft a plan. So I cannot give you a plan because it really depends on which pathway that you want to take, right? But the generic way of looking at it is that, okay, understand data science, pick the one that you like, okay, and then pick up the tools and follow my 1, 2, 3, 4 steps, right? And then you pick some topics that you will love, okay? And for the rest of the series, I will show you different case studies, different use case, and where to get those data sets. So feel free to stay tuned and come back again tomorrow 9 o'clock. Hey, but the thing is, after tonight, craft a plan. All right, if you're not sure whether your plan is viable or not, you can always drop me an email, Dr. Lau, drlau@thelead.io. I'm more than happy to help you to assess your plan, or to help you to check whether your plans are viable or not. But yeah, this is a general rule of thumb, because a lot of our students, they are professionals, they are working professionals, they are not university students, so they don't have the luxuries of 2 to 3 hours spending that sort of time. Yeah, but at least spend 1 hour a day for 12 weeks. And I'm not saying 12 weeks non-stop 7 days, but 5 days. All right, so 12 weeks times 5 days is about 60 hours. It's more than enough for a normal person to pick up data science, as long as you follow my recipes, okay, this framework. And last but not least is number 5. Yeah, number 5 is very simple, is to build a portfolio. And this is not just because you want to get hired, but a good portfolio should tell people that why they should hire you. Yeah, you don't just build a portfolio to showcase or to show off your work, but you need to be able to use your portfolio to convince people that why they should hire you. Good data scientists, they don't have to submit resume. Okay, a lot of good data scientists, whether my friends, my students, or my hires, right? Well, some data scientists, data analysts that I hire, they shouldn't have to submit a CV and fight with other people. Resume, CV, it could be a ticket, all right, an entry ticket to the game. Yeah, I'm not saying resume is useless. I never make that sort of comment. Yeah, degree is useful, resume is useful depending on when you're using it. But portfolio especially is very important because it makes you stand out from other people. Yeah, a good portfolio will tell you why people should hire you. You can build your portfolio in different ways. You can use Quora to build out your credentials, your portfolio. You can use Medium to write blogs to talk about it. You can use LinkedIn to write posts and activities, and I think LinkedIn have long form posts as well, right? You can blog about it, and if you like the challenge, you can build a personal website of yourself using GitHub and GitHub pages, or host your website somewhere else. Yeah, the methods that I'm sharing with you, they are proven, working, effective. Most important thing, they are free or very cheap. Yeah, like if you need to buy a domain name, say drlau.com, it's only $10 per year, which is 30 ringgit, 40 ringgit per year. Yeah, if you divide by 12, it's about what, 3 ringgit per month. Yeah, it's very cheap, plus a bit of hosting. Yeah, for less than a cup of Starbucks coffee, you can host your personal website. Yeah, that displays your portfolio. Okay, so to recap, I think we're going through these 5 steps again. First one is to understand data science. Second one is to choose your specializations, and the third one is learn the tools, right? Learn the important tools for the task that you want to do. And then number 4 is to craft a plan. Yeah, you definitely need a plan if you want to break into data science. And last but not least, build a portfolio. Now, your portfolio needs not to be highly technical. Yeah, your portfolio can be business, can be analytical as well. It doesn't really matters. Yeah, most important thing is you have a portfolio so that it serves as a purpose to tell people why they should hire you. Alright, thank you very much. Bye for now.